Dear students, welcome to CAD lab design and detailing practice, which is as per the 6th semester syllabus of SCTEVT for civil engineering students. The subject number is PR3. So the experiment number is 2.1. So the aim of the experiment is to develop a 2D modeling of structure using structure wizard, geometry, property, support, loads, and combination in Staad Pro software. So let's create a model for this problem. So we have a problem. It is a simply supported rectangular RCC beam of size 300 mm width and 700 mm overall depth, subjected to uniformly distributed load of 5 kN per meter over the whole span of 5 meter. And there is also a concentrated load of 10 kN, which is acting at the center. So let's model this using the Staad Pro software. So let us model this beam using the Staad Pro software. So for that, we have this screen of Staad Pro, the main window. So how to do? So we have to click on the new project and click on space. Let us the file name, give some name to the file. Let's say that is ASS beam. That experiment 2.1, and this is the location where we have to save this file. So also you can change the path of the file where you have to save this file. So in the next, the length unit are in meter and force unit are in kilonewton. So nothing to change. So click on next and just finish. So now a main window or the workspace will open. Here you can see we have a grid that is we just see the left hand bottom corner. We have the XYZ coordinate. We will change the view. Just see this is the x-axis and this is the y-axis. Along x-axis we have 10 cells, and along y-axis also we have 10 cells. So from 0 to 10 and 0 to 10. So each distance, each unit is 1 meter along both x and y direction. And here also you can see that is x-axis and y-axis in this direction, and z-axis is perpendicular to the screen of the computer. So let us design this or this model, this beam. So click on first 0, then go to the right, move towards the right along x-axis and click on the 5. So next you click on the general. So you can see the beam, the model or the figure of the beam has been modeled. So if you want to know what is the size of the beam, so just click on this icon or dimension and the dialog box will come. Here there is a display, click on display and dimension to view and just click on display. So as you can see, so this is a 5 meter beam. So this is the 5 meter simplified beam has been created. So now you have to assign the section. As you remember from the problem, that the section is a rectangular section having width 300 mm and the width of the beam is 700 mm. So here click on this section database and define. Click on define. Click on define, and here you can see the property, and here there is rectangle. So the depth, that is YD, that is 700 mm or 0.7 meter, and the ZD is the width of the beam, that is 0.3 meter. So just click, and the material is concrete, so nothing to change. So click on concrete, dot, close. Now we have to assign this property to the beam. So it is selected. So there is blue line is there. Just click on this beam and the red, it is selected now. Here the assignment method is assignment to selected beam. Now just it is selected, it is also selected. Now click on just assign. Now it will save. Now you see the beam is assigned the property of rectangular beam having size 300 mm and 700 mm. So just to view that, just right click on the screen and you have a 3D rendering. Click on 3D rendering, you just see the image will form. This is the 3D view of the beam. You can see the width and depth. So having length of 5 meters. Okay. Now we have to assign the support. So click on support here in the left hand side. So here there is no support is assigned. So we have to create a support. So here you can see a dialog box will come for create support, and as it is a simply supported beam, so that is a pinned support. So you click on pinned and nothing to change here. So just click on add. So now you can see as in the support dialog box, the S2, that is support 2, is there. So you have to assign that support to the beam. So click on support 2 and click on this point as the supports are at the ends and assign. Here you can see the left hand support is assigned, and the similarly click on the right hand support and click on assign the selected node. And yes, so the as you can see, the beam is having the support at both the ends, having simple support or pin support. Okay. Now we have to assign the load. So for load, we have click on this load and definition. Here the load definition dialog box will come. So first click on this load test details. Just click on add. So here a dialog box will come. That is the number 1. So this is the first type of load. Generally we have two type of load. One is the self-weight, that is the dead load, and another is the live load. Again, for live load, we have two type of load. One is a concentrated load at the center of the beam, and an UDL over whole span. So for first one is dead load. Click on this, scroll down will come. So click on dead and add. So just see there is a load case 1 is created, and for load case 2, it is a live load. Load case 2 a title. Also you can change the title. That is UDL. You can so write, but right. So dead load, we have two load cases: load case 1 and load case 2. So first load case 1 is the dead load. So there, click on dead, load case 1 and click on add. So a dialog box will come, that is the self weight. Here, as you can see, the load direction is the perpendicularly downward, the y direction. So the factor is -1 because downward, for downward it is -1, and the direction is y direction. So just click on that is self weight. So add. So as you can see the self weight is assigned, and here then load case 2, just again click on this load case 2 and click on add. Here there is a member load. We have two member loads. One is UDL, another is the point load. So for UDL, the intensity is 5 kilonewton per meter, which is acting vertically downward, so -5 left right. And D1, what is D1? D1 is the distance between the starting point of the load and starting point of the beam. So as the load is from end to end over the whole span, so D1 will be 0, and D2 will be 5 because it is the load is covering the total length of the beam. So as the span of the beam is 5 meters, so 2 5 meters. D3 is the distance between the center of the point of application of the load and the edge of the beam. So it is centrally acted. So it will be D3 will be exactly 0. So just click on add and close. And another load case is there. So that is the member load, the concentrated force. You click on concentrated force, and the value is that is 10 kilonewton. So you add that is -10, and the D1 is the distance from the point of application of the force to the edge of the beam or the end of the beam. So it is centrally acting. So total length is 5 meters. So half will be 2.5 meter. So D2 will be again the eccentricity of the load from the center. So it is axial load. So no eccentricity. That means D2 is equal to 0. As you see from the diagram also. Right. Now the load is taken, but it is not assigned to the beam. So how to assign? So just click on this. As you can see, there is a question mark here. 3 red question marks are there. That means it is not assigned to the beam. So just click on the self weight, and here click on this beam. So just assignment method, you click on this assign players or beam, assign. So just see the change. It is green means the load is assigned. Next is the UDL, and here same method. So UDL and same for this concentrator force also. Okay, so now you can see the beam is there. It is assigned the load, the UDL, and point load which is acting at the middle. Okay, so that's how we'll model a simple problem using the Staad Pro software. So the analysis part, how to analyze this beam for RCC calculation, the reinforcement calculation, all these things will be discussing in the next video. So that's all from this video. So thank you for watching. We'll see in the next video.